Now, we are going to have the panel discussion. I would like to invite John Unser, who was mentioned before by Joe Fox. He is collaborating with Joe in IACMI in the construction and infrastructure group. And Joe is, of course, online. And we have about 15 minutes for the panel to take questions from the audience.
I'll start. Great, John. One thing I think we talk about, but it would be really cool to monetize, and I heard a presentation a decade ago that the DOT causes more damage due to road closures, delays, traffic than their entire budget. How do we take that and take a bridge that's going to take 3 months, and now we're going to take it and do it in 10 days by prefabrication, being on site? What monetary value? How do we capture that and bring it into our metrics?
So part of that has been captured in life cycle cost analysis. But, much like any mathematical model, it really depends on where the balance and the weight is of the various categories that are over the lifespan of that structure. I think all of us in the room can say, if I see another orange cone, I am going to scream. So, the consumer, I know you're laughing, Joe. The consumer is wanting to certainly, what can we do better? And I don't think we have to go over the, hit the top of the mountain. Even if we hit the summit, it would be great. Mid-mountain is great too. But we need to show that sort of improvement.
I will just add that I really think engaging with the end users and getting them to help quantify it. So for example, Steve Nolan actually sat in on a lot of the meetings on that offshore wind project that Anthony Busel was doing. And when we said you could save 600 tons of concrete, I had gone online and found the average cost of a ton of concrete. And I said, so that's the potential savings. And Steve said, no. That's the cost of the raw material. The installation cost is like triple that. So you've got to have that end user addition to say, not only are we buying it, but what's the cost of installing it? I'll give another example that I just learned at the Bridge Conference. Okay, there was a very good presentation about a seawall that has been constructed in Charleston, South Carolina. And the professor who was giving the presentation said that because they were using FRP rebar, they had cut the construction time in half. They did it in 4 different phases. And by the time they got to phase 4 and were using all FRP, they demonstrated that they had cut the construction time in half. So I think you've got to have the end users adding to the equation. It's not just material costs.
Thank you, Joe, and John as well. Great answers. And we invite the audience to come forward. We have 2 microphones on both sides. Yep. Go ahead.
Hi, Zuyang Yu, UMaine. First of all, I'd like to thank you, John, for your very comprehensive presentation that gives a great review on how FRP can be used for different civil engineering applications. One of them actually is about the use of GFRP for strengthening and repair. Actually, I did a PhD on that many years ago. But I'm still surprised that in Massachusetts, we don't see many of those applications used by MassDOT. I'd like to know your take on how to convince state DOTs to embrace amazing, durable technologies like FRP. Thank you.
I think it's really simple, having a champion at the DOT. I guess it's now probably 20 years ago, I gave a presentation at the Mass DOT headquarters on, the world of FRP. And a couple people in the audience at that time had experience with structural strengthening of concrete, but that was it. But they didn't know about piles. They did not know about bridge decks. They didn't know about girders that were built even by that time, albeit on the front end of the technology. But I never saw Mass DOT embrace that. So not to put, emphasis on, leadership, it's all about taking the risk. I was a part of a federal highway traveling education program on alternative rebar technologies. So I'm in the room with, epoxy coated steel, galvanized, corrosion resistant steel, and then stainless steel, and me, the FRP. So after an entire day of everybody looking at corrosion, slides and stuff like that, I gave a big relief, and I'm saying in my presentation, I have nothing to show you with corrosion slides because we don't corrode. But at the end of that, the chief engineer got up and said, and I'll try to do it with the right accent. And this was in South Carolina. And he said, son, we are a galvanized state. And we only like galvanized. So I appreciate all of this, but we like galvanized. Okay, so when you're faced with that, it becomes, how do we open up the broader sense of opportunities and what they will get in return?
Galvanized FRP rebar.
There you go. Yeah.
I think I think that's one of the key for all these guys' organizations, like these organizations like this, TIDC and like that, is the education. That's key to it. That's really what IACMI tries to do, is you saw the education and that's really, and if we can find the group, find all the, be able to go to the DOTs and get that education, get an education program through, the ARBA program, that's the way to go.
Do we have other questions from the audience?
I was going to comment a little bit about the LCA. One of the things that we struggle with is the way they do the life cycle cost analysis is really geared toward how many cars and stuff go over the top of it. And that for any time you do like life cycle cost analysis for a small rural bridge, we're not getting many prints. It makes it really hard to justify doing those projects. And those are always a requirement for like a DOT. Or a grant for a federal grant or something like that. So it's really a challenge. So we need to kind of think through how do we do that. And I think Ohio or something like that, Indiana is looking at a different way to give that return on investment type of thing to the smaller companies, smaller towns and stuff like that. So that's a challenge I think we need to be addressing too.
But John, shouldn't all the DOTs be thinking the same way too? Shouldn't they all have the same needs? So everybody has a vested interest.
Yes, I do, but they've got to have a way for like the small rural communities. The justification is required because of the amount of cars that go over the top of it. And that's how they calculate the life cycle cost analysis. And that makes it hard for the rural communities to justify the programs.
Right.
Sorry.
We have a new question.
Hi, Mike Greenfield, University of Rhode Island. I've got a question that's very naive, given my lack of background in composite materials, but I can understand how the DOTs who have so much experience dealing with corrosion problems and how to search for them and fix them. I can understand that they'll be then asking the question, with the composite materials, it's great that they don't corrode, but what are the failure mechanisms that lead to concerns, and what are the failure mechanisms that need to be looked for over this 10, 50, 100-year lifespan of composite bridges?
Good question.
Good question. So that's very well known, number one. And it's not always the same answer for the type of product, and it's also for the application. But those failure mechanisms are known. Things have been tested quite a bit. Even to get to that ACI FRP rebar code, we just didn't make up the equations. We had to validate that on failure mechanisms, what the serviceability was going to be. So what I was trying to do in my presentation was to show, here's the evidence of a lot of back work that was done over the years. So.
And I think there's more like the standards again, within goes there's like I think it's NIHR. Anyways, there was a FRP bridge deck inspection manuals set up in like 2006. So those are the documents that they're out there and give you, the ratings and things like that associated with it. And those are documents that we need to update for that, so they can have the inspections thing like that. And that's one of we updated that document for our bridge deck component, something like that. But that gives you kind of some clues on where the pictures are really outdated and things like that. But those are things we need to update. I think things like the health monitoring systems. We keep saying data. We got to get a lot of data to show composites are being able to use and things like that. So I think the self-monitoring systems like fiber optic sensors and things like that will give us a lot more data to be able to show that. I think you guys are also looking at like accelerated aging program. So how do we show that, the 50-year, how do we know that it's 50 years life other than, we've proven it in other technologies like boats and stuff like that, but we don't have that evidence in place right now.
Well,
Right.
Well-
I will briefly touch on accelerated aging during my talk this afternoon. Yeah.
Looking forward to it. Thank you.
well, and to that end, the information is there, but it depends on, and I think, Joe, you brought it up in your presentation. I think about the first CFRP, so a carbon fiber tendon was used in a concrete bridge in Winnipeg, Manitoba. And we're talking I think about a 2.5 foot deep concrete beam that was under the tutelage of Dr. Sammy Riscala. And in there, they had Bragg grating, which is a non-destructive fiber optic type system. And that bridge was installed, and they looked, they were watching this for a better part of 5 years. And they noticed absolutely no stress, no degradation, nothing. So they turned it off. So that data exists out there on, iconic structures, but it resulted in, there was no movement, there was no changes, and visual inspection confirmed a lot of that.
John, I think he's bringing up a really good point, and let's take it to the next level. Somebody's going to crash on this bridge. A tanker car of fuel is going to explode and burn on a bridge.
Right.
A barge is going to hit a bridge, and they haven't even asked the questions yet, but they're going to come. How do I know what to do? How am I going to fix it? How am I going to repair it? What am I going to do with it? And I think we should start getting ready for those.
Well, and that discussion is already happening. So first of all, GFRP reinforced concrete barriers have been crash tested. And there are some great videos out there that shows, trucks bouncing in and bouncing off, and the concrete barriers are standing strong. There's an all FRP bridge barrier that was put into place about a couple of years ago, and it's been certified last year. That, we see those, I'll call it the plastic barriers that are out there. Well, these are FRP and they're crash rated. So those examples are out there. We just need to take those examples and translate it.
We have time probably for one last question from the audience. I can ask a question myself, and I would address this to John Unser. If we heard from Joe Fox about the bridge that was installed in Tennessee, maybe John, you can give us a bit more details about performance, about plans to expand this technology, reach out to DOTs, commercialize the technology. What do you see next?
Yeah. So like I said, we've done a lot of data on this because we basically work with University of Tennessee and Luna Innovations to put fiber optic sensors into it. And so we did, and we installed it. We did a lot of testing on the bridge and be able to show, okay, here's the performance of the bridge with the dump truck going over the top of it, and it matches the predictions that we had and things like that. So we did do like a 2.5 year redo of that. So we went and did a full inspection of the bridge, of all the visual inspection of it, some little NDT type of work where, tap test type of thing to make sure everything's okay. We also did another dump truck going over the top of it. So we've got that data to show that the self-monitoring thing, and it is it has, like an early warning system. We've seen an example where a big dump truck went over the top of it and got stuck. So we know, and it flagged the system saying, hey, you've got something on here that shouldn't be on there. So those are that type of system like that, I think is very critical. Again, we've kind of, the composite technology that we have with Prisma Design is a composite bridge deck, and we're looking for partners to put that into place. We have been working through like different state DOTs, but going through their qualified product list. But the challenge is really kind of that risk. They're not all of them are, well, who else has done this? So we got 1 or 2 bridges out there. We just need to find somebody who's willing to. Also, the challenge is cost. The initial cost structure isn't quite there because you're not at volume yet. So that's always a challenge.
Thanks, John. We have a question from Dr. Vincent Tang as well.
Just really quickly, with respect, does anybody know in the room, just with respect to composites we have out today, the resin and fiber system, specifically the resins, how much of it is maybe sourced from American petroleum or petroleum products?
100%.
We have amazing resin supply in this country. The only thing we're dependent on is we have a lot of glass fiber coming from China. There's some domestic, but a lot of it is China. But the resin, you've got major suppliers.
Yeah.
There's absolutely no barriers. You've got 5, 6 giant suppliers that are aware of watching all these emerging markets too, that are growing and looking to expand into it.
Thanks for clarifying that. I think it's an interesting point.
And a good thing that you're talking to ACMA because we represent those resin manufacturers. So
You got a conference coming up.
yes.
Vincent, is that addressing your question?
Yeah, it does. It's an interesting point, I think, that we can also make about that it is completely American source. It is actually also a petroleum byproduct in that sense, or related product. And then it also has the sustainability angle. So I think those are good points to make.
Thank you. Well, we are on time for our break, and I want to thank the panelists, Joe, for all the effort to connect with us remotely, John Unser, John Busel, the questions from the audience,